Us, congrats on the first. And streaking. Nice. Okay. Oh shoot, I need to check. Is my tablet gonna work? Yes, it is. Okay. You know, I meant to look into that thing that you said about the hyperbolic angle. It didn't make sense to me at first. Or it still doesn't, but gamma is equal to cosh theta. I assume that has something to do with how they did that hyperbolic angle rotation and ended up with gamma. But it didn't seem directly true to me that cosh theta equals gamma. No, this is chapter 4. It was in Boost. Because, like, Koch has the Jasu, hey, thanks for the streak. Koch is like e to the x minus e to the minus x over 2 or something like that. And I wasn't sure what value of theta would make that equal to gamma. Slim, thank you so much for the raid. I hope your stream was good. I was running around this morning, so I didn't get a chance to tune in, but thank you. Um, the cool green hat is the most important part. Um, but no, I never mind, dude. Um, I don't care about the viewer count. We all got to start somewhere. Definition of theta in terms of relative velocity between frames. 420? Oh, that's oh. And they just yeah, they didn't do much work with hyperbolic stuff in particular. They just plugged x prime equals 0. Oh, what's up, Lucas? Yeah, Colorcon, the famous 420 equation. Of course, it involved hyperbolic tangent. Not you trying to flex how hard your questions are. So, wait a second. Okay, so Lucas, as soon as you ask your question, I'll switch over. But I want to try to verify what Benbox was saying. You were saying cosh theta is equal to gamma, which is also 1 over root 1 minus v squared over c squared. And then we can apparently use equation 420. 418 with 421. T prime equals gamma T. Oh, yeah, like an equating the coefficients idea. Okay, sure. That seems to follow pretty directly, but I'm kind of intrigued to actually follow this through and verify it. PhD students struggle with trivial for first year questions. I mean, yeah, I can't speak to being a PhD student, but I definitely struggle with questions that are like below me, which, not really below, but I guess we can do it in either direction, but we can take b1 minus van squared. And presumably that's equal to cosh. We would need some identities though. Um, Hyperbolic trig identity. We should, if there's a good like cheat sheet, I should maybe just post that in the. Oh hey, okay. This might be worthy of posting in the reading group chat. Okay, Lucas, I lied. I think this calculation will be short, so I'm gonna do this first, and then I'll look at your question. You had a gap between your teeth. Where's the Pythagorean for? Oh, I guess we. Oh, they're gonna make. Ugh. I don't want to calculate it for myself. Wait, do they even show the Pythagorean? Bruh. Oh, that's the Pythagorean. And okay, I guess we can calculate it for ourselves. Cos squared minus sin squared. Ah. So we divide this through by cosh. And 1/cosh is sech? Is that how you would say it? I don't know. Oh hey, that works out. Noish. Math works, it turns out. Hey gamer. Okay. Lucas. Sorry if there's background noise. There's like work happening out right outside my place. The city is apparently inspecting the place that I live in tomorrow, and so they're doing like cleaning around it. Yeah, I was taught to pronounce it cinch, cosh, and van, and we just never addressed in my classes the one overs. But I feel like people on Twitch pronounce things the complete opposite way of how I was taught to pronounce them when I was doing my degree, and I have no idea what's right. Grinch con them. Paper circle, take out a sector with the middle angle called alpha. The radius is r. What is the angle of alpha? Oh, I feel like I've done a problem similar to this. It was probably 2 years ago, though. Hey, Jampa, thank you for the kind words. Oh, that's awesome. So we've got a Pac-Man. Waka waka waka. If you make the maximum volume cone. I'm 90% sure that I've done this before. The volume of a cone, is it a third pi r squared h? Am I making crap up? It's a third of a cylinder, right? Yep, okay, I got it right. And so that means we care more about getting the biggest radius possible for the optimal volume. And the maximum radius happens when you just barely connect these two edges here, right? Like you don't overlap them at all, because otherwise you're increasing height at the cost of radius. Yeah, they will be dependent on each other. I don't know exactly how to work out that function, but I'm just thinking kind of intuitively here. We know the surface area of this cone. That's an important thing, right? Let me get the equation for the general surface area of a cone. We're going to throw out this pi r squared term, but I'm just writing it in for the most general formula. Okay. Oh, depending on alpha? Um, it should be. Oh yeah, I shouldn't have labeled. Yeah, this R is not that R. I did some bad labeling. The R looks like the eye of Pac-Man. Yeah. Maybe I should call the cones R capital R. Okay. Now we don't want the bottom because we're not making that, so I'm going to throw that out. Pac-Man eating a goldfish cracker. Yeah. Cone you end up with should have the same, should have S diameter the same. Why would that be so? So you're saying that my little party hat that I've drawn here, that the radius of that circle there is the same as the radius of the circle up here? My thing with looking at the surface area is that seemed like the most natural way to include alpha. Oh, you're, yeah, okay. Like this side of the cylinder here. Yeah. Okay, ND vines. Yeah, we need to involve alpha in here somewhere. The regular area, IR squared. But we need to multiply by alpha over 2 pi, if alpha's in radians. circle thing in the cone is the same as the head of Pac. Yeah, I don't see what you're saying there's something. Um, the rounded part of Pac-Man is the same length as the circle in the cone. Oh, like the circumference of the circle minus like that little wedge. Is the same as the actual circumference of that circle down there. Oh, yeah, I can see that. Okay. 2 pi r times alpha over 2 pi is equal to 2 pi capital R. Oh. There's a weird noise outside. I thought it was part of the song. I'm sure not sure. That's 2 pi minus alpha. And Divines, what are you trying to do with those equations? Fembox is calling. Shouldn't it depend on small r though, Fembox? I feel like you shouldn't just get an actual number. You don't think r matters? Oh wait, yeah, well, oh, never mind. What is the angle of alpha? Okay. Maybe it doesn't. Um, what am I doing? We know that. Hey, Walter. And he finds that system of equations looks terrible. I don't really know how you would do that. Pretty good. So we're trying to find alpha, like, Is it too stupid of me to just solve this equation for alpha and start subbing things in? I could definitely get this down to one variable. With the Pythagorean identity. Well, actually, no, never mind, I can't. Not, not with that. Oh, you know, it's probably not going to be relevant, but I did make the same mistake with the angles on the surface area. Cut out 18% of the circle. Sorry, just chugging my tea. Forgot to make it for the stream. Big R is equal to arc length over pi. Do I know that? Or what wasn't it? I thought this equation is where I address the circumference, or like the arc length equals circumference. Listen, I'm gonna go put my mug away. You want to call for math Olympiad, but the Olympiad requires pure intelligence. Doesn't matter how much you study. It matters a ton how much you study for the Olympiad. I don't really enjoy those questions at all, personally, but you need to study a bunch. Hey, Aziz. 41.25 out of 50? I mean, that's a... It's, well, that was for E and M, right? Like, it's not easy to succeed in a class like that. Checking something on Discord. Yeah, you'll just see Madison Lucas as in like physics. Hey, LT. Sum of your three midterm averages was less than 100%. Oh no. But for grad school, and you were doing physics, I think. Like, I definitely don't. I definitely couldn't say that I would do better. Um, Bum's third pi r squared h can plug things in, but I want alpha, right? Not the volume. Everything was graded on bell curves. Selby's and all of them. Okay, yeah, that's good then. um. Oh wait, you lost funding and sanity? Oh no, that's really crap. I mean, that's crappy to hear about both of them, but you just have like the rug pulled out from under you like that for your funding. Because you changed labs. Oh, calculate the derivative and reverse engineer. Oh, that's your idea. Um, yeah, I guess we can make it a single variable equation, so we don't have to deal with partial derivatives. We can take small r as a constant, right? In Pythagorean theorem, the h away. There's a very annoying noise outside right now. It's a little distracting. This is math on challenge mode. Can I banish you to the nether realm? And then we want dv large r, large and in charge r. Oh, that's gonna be an annoying derivative. Oh my god, the sound just keeps going. Wait. Okay, if I'm not stupid and or crazy. Hey, Triambeck. I think my mic might be picking up that sound slightly, and I'm sorry if it is. It looks like it's very quiet if it is being picked up. So hopefully the music is drowning it out. Well, if you're on Twitch, if you're on YouTube, there's no help on that. Um, this doesn't feel right. I need to get alpha in here somehow. Hmm. The PA directed were some things you wanted to do, both basic and applied. Oh, that's fair enough then. More relevant to your goals. Uh, as soon as I see a derivative like this, I kind of get nervous, or like the I or at least I the goal is to solve this is to get alpha, and I don't know how I'm gonna get alpha with this equation. Is there a different substitution I could have made rather than small r? I feel like you shouldn't need calculus for this, to be honest. I think you should just be able to say what the shape looks like. That's my gut feeling that you shouldn't need calculus. You would have made that substitution? I mean, were you just doing partial derivatives then, or like how are you doing it? Hey, Prim. Hmm. ALE exams? I've heard of them in the UK. I've had people give me some questions from them before. They tend to be pretty tough. Well, for like A-level, like further math can be tough. I think the regular math isn't as bad. This one's letting r equal 1, and big R equals this equation dividing each side by 2 pi. Me trying to follow your train of thought here. Um, since big R and alpha are related linearly. Oh yeah, because we of that relation. You can then optimize r squared h with respect to r, and once you find the optimum, solve for alpha. Okay, so I think it's more or less what Jesse was saying as well. And it's basically what I did there, but I did a different substitution. Let me quickly address cubric. How do trig functions have inverses? The condition for inverse functions is they should be one-to-one and onto, but trig functions are periodic. And as Mert says, we restrict the domain to do that. So just kind of quickly doing it for sine. That's y equals sine of x. If you do the inverse, when you reflect it across the line y equals x, you'd end up with a sine wave that goes along the y-axis instead, ignoring the vertical line rule. But in order to make it be a function, we cut off everything we need to until it follows the vertical line rule. So that's how you end up with just that little, I know, it always reminds me of like a DNA strand for some reason. And so back over here, we restrict the domain of sine of x to just be that little piece in there. And that part does flip cleanly across y equals x. And that's why inverse trig functions are so weird. Like, you can't always trust the result that you get from them because this only covers 2 quadrants of the unit circle, so there's 2 other quadrants to worry about. And there's all the other solutions when you add or subtract 2 pi. But yeah, that's kind of like the quick thing. Well, you can make a function be one-to-one if you restrict its domain enough. Is passing through the origin necessary? Not to have an inverse function, no. Like cosine is a good example of one that doesn't do that. The inverse of cosine is just going to look like that. It doesn't pass through the origin at all. Yeah, or you can do like a multiple. I mean, I was hoping to avoid calculus with this, but I guess we maybe can't do that. Or at least there's been 2 people now who suggested using calculus. If I keep my work going, we can get rid of the small r then. Like, this equation is just kind of ugly. But we definitely can. Okay. This work is going to be all over the place. We can take this equation here and plug in this thing for big R and eventually isolate alpha though, for sure. I think it'll be easier to just isolate R first though. I think that's what Slim is saying. Substitute alpha everywhere, it's more annoying, easier to just take the derivative. R squared root 1 minus R squared, then do the derivative equal to 0. Quadratic formula gives you the best R. Yeah. And so I included the 1/3 pi. I guess I can just divide it out in this step here. I'm also going to multiply through by root 1 minus R squared. So we're going to get 2R1 minus R. Oh, I'm getting cubic. Unless one of these R is going to factor. Oh yeah, the cubes will cancel. Okay. Wait, isn't this getting... Oh no, the cubes don't cancel, but it's really simple though. Oh, and this is the quadratic because r equals 0 isn't very interesting. So r is plus or minus root 3 over 2? Nope, nope. 2 over 3. And so we can now, well, we don't want a negative r. So we can do just the positive. And now we can worry about that. Um, okay, I think that's my answer. What did you guys get? We might have gotten the same thing, Fembox, just you factored it differently. We have the same thing? Okay, it looks like it. I'm not going to bother actually writing it out. Okay. It'd be nice to find a non-calculus way of doing this, but this definitely works. You might just need calculus for it too. It just feels like there's a geometric way. Should have at a sign mistake need a minus. Oh, do I have a minus? Oh, okay, yeah, I have a minus. Okay, thanks for the question, Lucas. Um, I don't think we have any other questions that are pending. Confirming that. I don't think so. So maybe back to linear algebra. I think I was working on this one the last stream, but I didn't actually do it. I feel like the projection of B onto A, it, like, we just erased the 4, don't we? I guess it will be a 0. Is that? Too easy? No, I think that's just it. Because the column space of A is just R3. And so I think any projection of a four-dimensional vector should just involve getting rid of the fourth dimension. I feel like it. We can verify this. But I'm making the call that PB lead is equal to 1, 2, 3, 0. That's what lead equals, everyone. Next week we'll do cadmium. Technically, we have an arrow there. But we do need to find the actual P matrix anyway. What shape is a projection matrix? P? Oh wait, should this be four-dimensional? Wait, what is the... A transpose A. This is 4 by 3. A transpose is 3 by 4. So inside we have a 3 by 3. And then we have 4 by 3 times 3 by 3 times 3 by 4. So it's going to end up being 4 by 4, right? Yeah, that makes sense. Okay. And then I assume we just have to go through this annoying formula to find P. Maybe, I mean, could we just figure it out? Would it just be, would it just stick a column of zeros on here? That's my bet. I'm gonna make the call that P is just gonna be the same thing as A, but with a column of zeros. Let's actually do these calculations though. Can I mental math my way around A transpose A? It's a 3 by 3. I feel like it should just be the identity. I'm pretty sure it's just the identity. Let me write out A transpose. Actually, I need to write out A transpose on the right anyway. So that times that. No. It's... Yeah, this times that. In that order. So it's that column, that row. Yeah, we get a 1. Uh... 0, 0. 0. Yeah, okay. I'm just going to say this is the identity. It sure seems like it's going to be that. So we don't care about inverting the identity, and then we don't care about multiplying the identity. So we just have A times A transpose. And so we're going to do that column, that row. It's a 4 by 4 now, though. So 1, 2, 3, Okay, I'm not going to do that for every single one, but do 0, 0, and so we know that anything involving that column is going to be all zeros. And so this last column is all zeros. Oh, is everything going to come up Milhouse here? I think it is. I think what I called it being before is true. Yep. Okay. So I'm glad I verified it, but I did call it. Now we should check my what I called PB as well. But no, that just works out. 1, 2, 3, 0. Okay. So that's an easy way to chop a dimension off a vector, I guess, if we need to do it with matrices, is the point of this question. All right. Where should we grab a question from next? Kind of tempted by 4.4. 5.1 might be helpful, but I feel like the properties aren't that bad. Hey, Yash. I haven't gotten to 6.5 and onward. Have I done 6.4? I don't know. I don't think I have either. Wow, so from chapter 10 on, it's basically just applications and applied stuff. All right, let's go 4.4. I think I pulled questions from this book before, but I want more. More. No, I'm just saying, if you have a question, Yash, I can work on it. I'm just looking for like a study question while I wait for someone to ask a question. I think Graham had the idea. I don't really know where Schmidt came in. Frickin' Schmidt, dude. Who even likes Schmidt? Ha, cutie. There's gotta be... That's gotta be a linear algebra pickup line. Like, hey babe, are you an ortho... Are you the transpose of an orthonormal matrix? Because you look like a cutie to me. Schmidt probably got the pizzas and got some credit. So I used to doing group projects in school. If it works, it works. Kruskal algorithm? I've had someone ask me about that before. I remember explaining this to someone at some point, having not seen it before. I think. What's your question about it, Yash? Foodie, I don't remember your doubt. What was it? Oh my god. There's the annoying noise outside his back, and it's really bugging me. Ugh. Oh, you're just curious? I've like looked at it barely enough to try to understand it and help someone with their question about it. I don't know it that well. Oh, is it the cheapest way to get from one point to the other? Or it's the cheapest way to go around a graph, maybe. There's an algorithms class for forever ago. I don't remember learning it if I did. I remember having to do like Dijkstra's algorithm. Any connected graph has what is called a spanning tree, a tree that touches all nodes of the graph. Okay. into Kruskal algorithm will get us the minimum spanning tree, which is the spanning tree with the minimum weight. Yeah, no, yeah. I was curious to remember like what these terms even mean, but I'm gonna move on in a minute here. Oh yeah, Foodie. I'll put the question up. I don't think I know how to do it though. I think that's what I said the last time. Um, the terrible thing to do here would be to make a system of four equations. I mean, is there a linear algebra way of learning about this? I don't know. Uh, well, yeah. I guess what I meant when I say like, is there a linear algebra way? I mean, like, is there a linear algebra way that actually helps? I guess. um, 1, 1, 1, 1, 8, 4, 2, 1, 27, 9, 3, 1. 64, 16, 4. So like, but this would get us like, this is like the brute force way, I feel like. Because this would get us the actual polynomial that would then plug 10 into, but I feel like there's some fucky way you can get straight to f of 10 without having to do all this. Yeah, something like Slim was saying. The k is an x, yeah. Oh, yeah, it should be an x, I think. I guess f of x plus 2/3. These k's become zeros. Isn't that going to be a quartic? Yeah, that doesn't make sense. What the hell? Yeah, that's a fourth degree, Slim. Oh, wait, that's okay. Uh, is it okay? One, two, three. Wait, yeah, this is degree 4. This problem isn't possible with a cubic. So I'm gonna make that a 4 because it's just not possible as written. Hey, Rushback. And I'm making it X. Where are you getting your 3 factorial from? That seems a little random. So, this is what Slim is saying. Mert is saying to divide a 3 factorial there. Oh, that was the mistake that you made? Okay. I mean, can't we just plug 10 into this? And that's our answer? Like do we just do the question? Mental math? 72 times 7. $500? 4? $72 times 7. Yeah, 504. 504 times 6 is 3,000. I lost it. It's 504 times 6. 3,024? If I did that right, I'm going to demand a field medal. The answer should be 25, apparently. You can get a degree 3 polynomial? How? You can divide the right hand side by... Oh, there's leading coefficient problem, Fenbox is saying. Well, yeah, Luber, these have to be on a horizontal line is the issue. I can't think of a cubic that has 4 points on a horizontal line. This noise is fucking torture to me right now. It needs to stop. Oh my god. I can't think. I don't think my mic is picking it up, but there's like cleaning happening outside, and it's just a constant, like, high-pitched buzzing noise that's been going on for like 10 minutes now. Oh. F of x equals 2 over x? How? I don't know how you would get that. Or minus 2 over x? Actually, no, I don't think we do have leading coefficient problem. Because if we have like a one... Wait, do we? No, maybe we do. What is that possibly? Sorry, guys. I have to look. This noise is so. I can't see where it's coming from. Yeah, Foodie, I have no idea where the math you're putting in the chat there is coming from. Apparently, you can somehow figure out that xf of x is equal to minus x over 2. That doesn't seem like... Or to minus 2 over x. That doesn't seem like it could possibly be true. Ubird. I don't know where that's coming from. Is that some weird thing to force this 2/3? Is that where that's coming from? Zero problem means degree 3, but it's actually k. I do feel like the problem wasn't correctly put in the YouTube chat, Foodie. There's definitely something wrong with how you put the problem originally in the chat. You want to Desmos it? No, it can't possibly be degree 3. And you randomly had a k here. Like, this is how the problems were just stated, and this statement makes no sense. Given points x1, y1, x and yn. Oh, Lagrange. Oh, that's interpolation for the polynomial. Or at least The kth derivative? JA questions? No, I can't. TSG. Like, Foodie, is it like Academy of Useless Ideas is saying, like, is this supposed to be like the kth derivative? So I feel like we're solving the wrong question here. Okay, so that makes the question completely different. I wish that you said that before. I can solve basic trig. If it's trig from JEE, I can't solve it TSG. JEE trig uses the most vague identities that no one has ever heard of. And they make you do like 2 pages of math for a simple problem. Or well, it should be a simple problem. Well, actually, even then, this doesn't make sense if it's the kth derivative, or we need something more to go off of. Like, f of k equals minus 2 over... Oh my God. This is just a different question. Sounds good, Bluebird. Thank you for your thoughts there. Yeah, teach you where if you want to just put your question there in chat and I'll tell you. But um, I mean, put it either there in the YouTube chat or put it in my Discord. Okay, yeah, that makes sense, I guess. What the hell? Um, I guess we can do x's there. Well, it's only for certain x's, but no. Maybe we should have k's on the right. I'm gonna use an a here instead of a t because my t's look like pluses. Yeah, and interpolation would definitely work here too. I imagine there's a nice way of doing it like this. Differentiating it? I don't think we would need differentiation. Uh, Jad, normal to a line and plane for linear algebra? Are you talking about like projection or what do you mean? We can find a if x equals 0. Oh. Uh, f of x is third degree, but x f of x is fourth degree. Yeah, and the problem was written wrong a few times. No, I think the problem works out now, but Foodie, you need to make sure you're writing the problem right in checks. Like, we were all just solving the wrong problem for like 15 minutes. um, and now we can just plug a 10 into this. It's chill tunes. Good, good. Uh, 9 times 4 times 7 times 3 minus 2. You said the answer was 25? There's no way it's going to be 25, though. That's not good. 9 times 7 is 63. 63 times 4. 63 times 4 is 252? I'm welcome outputting this. Fuck it. A 4 from the 12 canceled the 8. A 3 from the 12 canceled the 6. Oh, yeah, fair. 2. Because math is hard, that's why. Okay, 252. Oh, wait, so it does come out to be 25. Okay. There we go. Okay. That's that question. Jad is putting a new problem for us to work on. Point normal form of the equation of the plane passing through point B having n as normal. What is the point normal form of an equation? Oh, I bet point... Oh, isn't this just plugging and chugging? I think the point normal form of a plane is a x minus x naught plus b y minus y naught plus c z minus z naught equals 0. We can verify that, but I'm pretty sure that's just the equation. And p is x naught y naught z naught. N is abc. P minus... Oh, that's how you construct this? I guess vector p minus vector x dot n equals 0. Oh, I didn't really know that. That makes sense, right? Yeah, no, Jad did say linear algebra. And so I like this way of thinking about it more. Well, don't I have x minus p? It probably doesn't... Oh, no, it should matter, right? How is this sound still happening? Oh my god. Sorry, I get bothered really easily by annoying sounds. I'm gonna be complaining about it. Um, why is it p minus x and not x minus p? Oh, really? Zach and I like secretly like live right next to each other, even though we're in different states. Conspiracy against math Twitch. You know, I believe it. The physics streamers are trying to take us down because mathematicians and physicists are always fighting. Um, sorry, I'm still staring at this, trying to justify, or trying to think about p minus x versus x minus p. Because I'm looking at like, I'm pretty sure this is just the answer for like the one that I have memorized, but that's x minus p. It's okay too? Okay. The 0 is negative 0. I was thinking it would change. Oh, you're right. Never mind. Okay. Yeah. And how do we interpret this? So we know that any vector inside the plane, which is what x minus p or p minus x is, if you dot it with n, it should be 0. Because if you dot something and you get 0, it means they're perpendicular. And so the vector x is the variable x, y, z, or like, you know, the vector of variables x, y, z. P is the point that we're given, and n is the normal vector. Okay, neat. I didn't know that interpretation of it. So like I could also write this as just to really like spell it out. X, Y, Z. 1 minus 3, 4. Dot minus 1, 2, minus 2 is 0. And so this will just give you this, but we can, like, you said linear algebra, Jad, so I'll follow it through with this. because that's the kind of linear algebra way of thinking about this. So inside the parentheses, what we get is x minus 1, y plus 3, z minus 4, dot, minus 1, 2 minus 2, equals 0. And now we do the dot product. Minus 1 times x minus 1 plus 2 times y plus 3 minus 2 z minus 4 equals 0. So any xyz pair that satisfies this, or not pair, but triplet, that satisfies that relationship is on the plane. And so you could also just like leave it like this, like maybe get rid of the 1 and just make it a negative. Yeah, I would just leave it like this. You can technically multiply everything out in group terms, but I actually would not do that for how the question is phrased. So I would just stop there. Okay. Don't you have any question about that, Chad? You understand it? Awesome. Glad to hear it. Okay. I don't think I pulled a new question to study from. So if anyone has a question, let me know. If not, I'm going to go back to looking for a study question. Oh, that's right. I was making up linear algebra pickup lines with Cutie. See the pile of dirt outside your house? Oh god. I've had someone like drilling or something and making some kind of high-pitched buzzing noise for like 30 minutes now, and it's driving me crazy. It's not going right this instant, thankfully, but it might start up again. I feel like I only started to get bothered by stuff like that when I started working in an office, and I would be trying to work while people were like yelling into their phones on a meeting. Or I remember like someone was really like voice acting and like doing something super strange, and there was no reason to ever have a voice actor in the office for the stuff that we were doing. I don't know. Gauss Legendre 1 point, 2 point, and 3. I've never heard of this. Uh, Legendre 1 point, 1 point man. Quadrature. Oh, wasn't Phobos studying this? Maybe you'll post something to Discord. I mean, piles of dirt are pretty cool. Um, what's happening here? Oh yeah, Jed. uh, Donald Knuth or how we pronounce it. Like I think he's like a really well-known dude too in computer science. I feel like you see his name in a lot of places. I definitely have heard of him. The dawn of the future, but in the past. Yeah. Yeah, I'm trying to understand what exactly this formula. Like, I guess the important bit is how we get our weights. Because this looks more or less like a Riemann sum, but you'd have to be really clever with your choice of weights to only use one, two, or 3 points and get anything that's remotely accurate, right? Oh wait, maybe no, maybe x sub I is important here too. Hey Victor, these are clever points and weights. Yeah, that's how it seems. I've never had to learn this algorithm for myself, so I don't quite know how it works. Maybe not Wikipedia will have a better explanation. Like they'll teach you from the ground up a bit more. More accuracy for the same order computational time over the trapezoidal rule. Pretty neat. Is that how farming works, Dessen? Or gardening? I thought you were gonna make it like a related rates problem where you're like the class problem that they give where like you have dirt on a conveyor belt and it falls down onto the ground in a cone. Is the playlist looping by the way? An hour and 52 minutes. No, not yet, but it will soon. They just kind of sound similar. What? Why would it do that? A good one with chemistry, not good at all. I've forgotten pretty much all the chemistry that I learned. You can try. It's not going to be streaming today, but you could try actual education though. He knows chemistry. Victor, your first time here, you'll be a part of this. How often do you go live? Oh, awesome. Well, welcome in, Victor. Um, I go live in my time zone. It's Tuesday, Thursday, Saturday, starting about 2 hours ago. Uh, if your time zone is, I'm in America. If your time zone is late enough, it might be Wednesday, Friday, Sunday for you. You did hear chemistry, Jasu. You ever heard of modified Newtonian dynamics? I don't think so. I learned about how special relativity modifies Newtonian mechanics. I don't know. I assume modified Newtonian dynamics is a different thing, though. Algebra 2? If you just mean like regular, like high school level algebra 2, yeah. You want just like put your question there in chat and I'll tell you if I can answer it. It's because someone's asking about Gaussian quadrature, and I'm trying to understand it. I don't think I can understand it quickly enough to explain it to this person, though. I'll drop a link to this in the YouTube chat, but I don't think I can explain this, Ishan. I'm sorry. Um, yeah, I'm 100% planning on reading that. I'd like to spend like maybe this week and next week trying to get through like introductory linear algebra, and then maybe the next week start cracking on complex analysis. And Sundaya, yes. I'll try and make it more clear. Like calculus and below is what I can do. So there's nothing that's too basic for me. If you start going past like calculus, it might be too hard. Kind of alternative solution of dark matter, just changing constants, barely not including relativity. Oh, interesting, Mert. Actually gives very good comparative experimental values. Nice. If you want to put a specific question for me to work on, Sundaya, feel free. Or Sunday. Oh, you're Sunday ASAP, I guess. Uh, but I don't know exactly what that is. um, hey, Papadoria. I'll think about that in a second. I guess it sounds like there's interest in it. I guess we can. I guess we could potentially do some type of reading group on complex analysis. Um, I need to figure out what I want to learn though in complex analysis and how I can fit that into the time that's available. Uh, uh, we said someone asking about Gaussian quadrature. I was trying to figure that out, but I couldn't. And then this was I was looking at orthogonal matrices, but I'm not going to do that right now either. Da, 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 da. Where is it? There. I I don't know how structured I'm gonna want to be about it, but I guess what I'll do is figure out what chapters I'd want to cover by when, and if people want to be along for the ride. Um, then we can maybe figure something out. Oh, awesome! I'm glad to hear that, Ishan. Um, Yasu, this person in the YouTube chat asking about Gaussian quadrature for approximating integrals, but I've heard of it, but I've never seen it before. Victor, I use Journal++ to write, and I have an actual like a tablet to write. If as I number theory is not my favorite. Okay, so Papadoria was asking, the bot flashing, do you know? Okay, so Papadoria is asking about something we were talking about last stream, which is the connection between Pascal's triangle and powers of 11. And Papadoria wants to know the proof of that connection. And my gut feeling that people were confirming is that it, well, let me just say 11 to the 0 is 1, 11 to the 1 is 11. Seen a few FemLux, 11 squared is 121, 11 cubed is 1331. And the important fact is that 11 is the same thing as 10 plus 1. Oh, do you do binomial expansion on that? That must be it. That must be the 11 to the n is equal to 10 plus 1 to the n. And that's equal to k equals 1 to n. And choose k, binomial coefficients, 10 to the n. Right. Okay. I'm actually doing something. Because let's do 11 cubed as an example. Yeah. From this formula here, oops, 3 choose, wait, it's k equals 0 to n. 3 choose 0. No, wait, I have this backwards. Why am I feeling stupid? No, this is fine, 10 to the 0. 3 choose 1. 10 to the 1. 3 choose 2. 10 to the 2. 3 choose 3. Squeeze it in, 10 cubed. So that's 1 plus 30 plus, well, let me write it like 3 times 10 plus 3 times 100 plus 1 times 1,000. And so these are the same 1331 that you see here. Doing algebra without being aware of it. I mean, I guess you could, well, it turns, I don't know what type of algebra you mean with that, doesn't it? Lang also has a book on complex analysis, maybe something you'd like. Okay. Suna, hey, I'm doing good. How about you? Do a minesweeper? Okay. Let me tranquilly explain to Havoc. Havoc asked me about polar coordinates and how to find theta. So let's just say in Cartesian coordinates, we have the point 2, 3. Why not? The polar form of this point is going to be, we need a radius, r, and an angle with the x-axis, theta. And so that was, it's not your question, but you would find r by doing the Pythagorean theorem. So square root 2 squared plus 3 squared, whatever that is. And you can find theta by doing arctan of the y value divided by the x value. Because you can literally set up a right triangle here with height 3, width 2. And this is often a job for your calculator. But that's basically how you would find it. Do you have You have to be careful with the output of arctan. No, I think arctan is okay. You don't have to adjust it for quadrants, right? Or do you? No, you do. Okay, yeah. The thing to be careful of is remember where your point is. Um, arctan will only ever give you values uh from negative pi over 2 down here up to pi over 2, or like basically negative 90 to positive 90. And so if you know your point is over here, say we have minus 2, 3, you're going to have to remember that arctan sort of lies to you. If your point is over here, it's going to give you this angle with the negative x-axis. But we always define theta as coming from the positive. So what you'd want to do to find the actual angle here is to do pi minus whatever arctan gives you. Hopefully this is looping. Or equivalent 180 degrees minus that. Let me switch up the music quick. Coefficients were before you put in coordinates. Oh, interesting. Yes, and I had to think about it for myself there too. Like, do you have to hear about that? 3 or 5? Oh yeah, right. Riemann sums? I can talk about them, yeah. Are you curious about why they equal an integral, or like what's your specific question? And while I wait to hear back, I'm gonna do the Minesweeper for Zach. Minesweeper.online. Where's no guessing? No guessing. What? No, take me to no guessing. Thank you. Was that hard? I can tell you right now I'm gonna misclick. No! There's the misclick. My fingers are cold. I don't feel locked in. Wait. Oh, okay, I actually messed that up. That wasn't a misclick. Trimbach, I play a little bit of chess. I'm not terribly good at it. I usually rage at it pretty hard, so I limit how much I play it. Oh, dude, I'm just not paying attention. No, I thought I'm ready to evil. I know how to do Laplace transforms. I don't know the interpretation of them, but I know how to find them. Okay, I need to force myself to slow down. I always like trying to do this as fast as I can, but it makes me misclick way more. There we go. Slowing down is a sure way to not get the world record. That's true, Zach. That's a pretty pitiful time compared to some of my other times. The rules for Minesweeper, it's just a lot of pattern recognition. If you feel in control, you're going too slow. Exactly. If you ain't first, you're last. Now, if my fingers aren't cold and I'm locked in, I can do that like in 30 seconds or so. What are we doing here? We're going over Riemann sums. How do I approximate expect class? Oh, okay, yeah. We can go over approximations with Riemann sums. Okay, so what function do we want to approximate? Let's take it's a good one. That's not too hard. Okay, let's take maybe a parabola that's facing down. Let's give us a good couple of points to play with. Okay. 1, 2, 3, 4, 5, 6. Okay, without being too exact, I'm going to draw the parabola. We know where its roots are. I'm not going to, and we know it's facing down. I'm not going to take too much care to draw the rest of this that accurately because we don't really need it. I'm going to say we want to estimate the area. 1, 2, 3, 4, 5. Okay. Estimate the area under y equals minus x minus 1, x minus 6, for 1 is less than or equal to x is less than or equal to 6, with n equals 5 rectangles. Okay. So I'm gonna need to be more specific with my problem statement here. But let me explain why. So if you have a function and you want to estimate the area under it with a Riemann sum. Riemann sum means we're making rectangles. But how you draw those rectangles is important. So if we have 5 rectangles, the width of each rectangle, which we call delta x, is equal to b minus a over n. And so b is the start x value. Sorry, a is the starting x value, b is the final x value, n is the number of rectangles. So this is a really good formula to remember for Riemann sums. So here it's going to be 6 minus 1 over 5 is equal to 1, because 5 divided by 5. So we're going to have 5 rectangles of width 1. So we're going to have a rectangle somewhere here, because we're starting at 1, a rectangle between here, and so on. Like, they're going to be split up like this. But the issue is, how do we determine the height of these rectangles? For a Riemann sum, there's 3 typical ways of doing that. And I should say, the area under the curve is this region here. And so obviously that's a curve. It's kind of hard to get the exact value for that until we learn about integration. So in the meantime, we can do approximations. And I'm going to do what's called a right-handed approximation, I think, to start with. Or is it just right approximation? Or using a right, I think it's called a right-handed Riemann sum. I don't know about the word handed in there, but basically what this means is the first rectangle goes between 1 and 2. That's our base. And the height, we follow the right side of the space up until we hit the function. So that point right there is going to be the height. And that's just f of 2, because that's the second x value. And that's our function there. So we can figure out what the height of that is. So let me draw this rectangle a little bit neater. Base, height goes right to the parabola, and then because it's a rectangle, we kind of fill in the rest. All right, and so that's the procedure that we're going to repeat. So now we're between 2 and 3 for our base. Follow the right side up to the function. That's how high up we go. Then connect the rectangle. Now we're between 3 and 4. Follow the right side up. Complete the rectangle. Between 4 and 5. Follow the right side up. Here's that rectangle. And then between 5 and 6, oh look, the function hit 0 right there. So our height is just going to be 0. And that's okay. And so let's kind of think about how good this estimate is. These rectangles on the left are contributing too much area. You see, they go a little bit outside of the parabola. So they're kind of contributing extra area. This rectangle in the middle is a little bit fuzzy. You know, I might not have drawn it well, so let's not think too hard about that one. But these two rectangles on the right, they're definitely not contributing enough area. They're leaving some gaps in the parabola. So I don't quite know if this is an overestimation or underestimation. It depends on how exactly we split things up. Maybe I should use a slightly different function for that reason. But just know that you can kind of graphically figure out whether you're going to have an overestimate or underestimate for a lot of functions. This one isn't great, but if I did a different function, like let me just draw something and not name what it is. If I had a function like that and I did a right-handed sum, we could be certain that's an overestimate because we can see every single rectangle is going to have too much area. Welcome back, Fembox. I think y equals x is too easy, but it wouldn't work well. So yeah, that's just like a thing to note you can do with Riemann sums. Like, not every time, but you can often tell whether it's an overestimate or underestimate. In the situation that I chose, it's a little bit sketchy, but you often can. Or they usually give you problems where you can. So to actually get this estimate, we'll say the area is about... No, we're just doing a regular Riemann sum. So remember, the area of a rectangle is base times height. So this first rectangle, the base is always delta x. That's always true. So it's 1 is our base times the height, which we said is the value of the function at 2. So we plug 2 into there. I'm just going to say f of 2, and we can figure out what that is later. Plus, now the next base is still 1. The height is now the function at 3, right? So f of 3 plus 1 times f of 4 plus 1 times f of 5 plus 1 times f of 6. I mean, y equals x is just a triangle, though. You don't need to approximate that. That's why I don't like it. Okay, and so now let's figure out what these actual values are. The 1 times we don't have to worry about here. f of 2, that's 1 times -4 with a negative in front. So that's 4. Wait, no, yeah, okay. F of 3. Oh, sorry, and I should say, like, we should have as many terms here. Like, if we have 5 rectangles, we should have 5 things being added here, and we do. F of 3, 2 times -3 is -6. Negative out front becomes a +6. F of 4, 3 times -2 is -6. Negative out front is another 6. F of 5, 4 times -1 is 4, -4 with a negative out front, so we get 4. And then f of 6 we already know is 0. So 12 plus 8 is 20. Okay, nice. So that's our right-handed estimate. I can get the actual answer for us here, because I know how to integrate. If you haven't learned this yet, don't worry about it. But this will give us the exact answer. 20.833. Okay, yeah, so we're a little bit under, but that's still like pretty close. Okay, so that's the basics of how you do a Riemann sum. I should teach you there's a left-handed Riemann sum and what's called a midpoint Riemann sum. Those are the 3 things they usually kind of Hey Sage. Those are the 3 types of estimates. Use Simpson's rule. Simpson's rule will be great for that, right, Zach? It's just a parabola. Let me quickly redraw the same parabola. 1, 2, 3, 4, 5, 6. Terrible. Oh, nice, Sage. Good luck. There's a lot of stuff there, yeah. So you can do what's called a left-handed Riemann sum. It's the exact same procedure, except we follow the left side of the rectangle up. So this first space from 1 to 2, that's just 0. Like, the function right there is 0. The next base from 2 to 3, follow the left side up. Then we get that. The next base is right there. Follow left side up. We hit it there. Next base, follow left side up. We go there. And then the final base, follow left side up, go there. I did not draw this to scale. It's index. But you can do the exact same procedure here, and it's going to look almost the exact same as our right-handed. The only thing that's really changing are the x values here. So I'm going to drop these 1 times. Well, actually, no. I can copy and paste this. Okay, so the first function, we started at the very beginning of the interval now. For the right-handed, we skipped the first point, but now we're taking it. So that's f of 1. And then we went to f of 2. And then 3, 4, and 5. So you can see, like, it's nearly the exact same thing. We just use slightly different x values. They're all shifted by 1. That's the only difference between a left and a right-handed Riemann sum, really. The final one takes a little bit of extra... Well, not really. The final one is a midpoint. 1, 2, 3, 4, 5, 6. What you do for a midpoint, draw your base, but then you determine the height by the middle of the interval. So this one's a little bit harder for me to draw, but basically like we take the value of the function right in the middle and complete that rectangle. Now this is our base, follow the middle up and go here. This is our base, follow the middle up right about there. The midpoint is usually your best bet, like if you have to choose just one thing for a decent approximation. Because it goes a little bit over, a little bit under, and you kind of hope they cancel out well. Of the three options. So if I bring this back, our x values now. This first one is 1.5, halfway between 1 and 2. And so rather than doing a bunch of fraction math, once you know your first point, just keep adding your delta x. That's how we're progressing. So delta x is 1. So I'm just going to keep adding 1 to 1.5. So we get 2.5, 3.5, 4.5, 5.5. And so then you just kind of plug in from there. But yeah, those are the kind of the three Riemann sums that you should be aware of. There's many more ways to approximate the area under a curve, but those are usually the first three that you're introduced to. So do you have any questions about any of that, Havoc? Is there a form of getting the axiom approximation? It depends on the approximation. Moment. If you can give me a specific question, I can tell you if I can do it. GCSE, I probably can do it. For getting the accuracy for like a Riemann sum approximation, I'm not sure there is a formula. There's definitely a formula for Taylor series, that's what they're called. But yeah, for Riemann sums, I don't know if there is an like a clean error formula. Yeah, I think GCSE is like the UK's like high school diploma equivalent. So hopefully will be able to do it. Tuna for Riemann series. I mean, maybe. Um, if I can find it quickly, Moment, sure, but I'd rather you just give me a question because I wouldn't know which one to choose that you need to actually have help with. No, I'm seeing a bunch of like general tutorials, but I don't know what specific types of questions you would want to help with. We can search for if there's one for a Riemann sum. The one for does Paul not go over this? Paul has to go over the. This is called the remainder theorem. Oh, Paul, there's no way you don't do this, Paul. Don't do this to me. I don't know if Paul does it. Paul has fallen. He has. Taylor series remainder. I am shocked that Paul doesn't do that. Paul's online notes. Lagrange remainder? Oh, come on, Paul. That's all the time in calculus classes. I'm kind of shocked. He talks about the remainder, but he doesn't give the actual thing. I know, Zach. I just like linking to Paul because the explanations are so like like succinct. Also, syntax might want like a little more robust. Um, this is the remainder of a Taylor series. It's like the actual function value minus the value the series gets you. This is the remainder here. And the way I remember, I think about it is you kind of go one more derivative out than what your Taylor series goes to. It's basically just like the next term, I guess. I forget why. My memory is just kind of sketchy, but that's how the formula looks at least. Oh no, it's not necessarily the next term. The C you have to find. Or you find the maximum. Yeah, you I forget it. Yeah, it's a weird thing. You find we don't know what C is, so we take the worst case scenario and find the C that gives you the maximum for the n plus first derivative. Moment, you can't post links in the YouTube chat. It just YouTube doesn't let you. So if you're posting a link, I can't see it. Riemann sum error. Let's just see if there's a. I don't think there's a formula for it for the error of Riemann sum. Oh wait, yeah, there is. Never mind. I'm just crazy. I've seen this before too. I've literally seen this, and I just forgot it existed. My bad. Um. I mean, I type it out there in the YouTube chat, or if it's easier, put a screenshot. You can put it in my Discord. C is the maximum between A and X. A is the point you're expanding about, and X is whatever your point happens to be that you're estimating. But yeah, I forgot. There absolutely are. You can absolutely bound the error for Riemann sums, as well as for trapezoids and midpoints. Yeah, I've seen all these before. I just forgot about them. Oh yeah, so I should say for people who were talking about complex analysis stuff earlier, if you are going to be interested in that, just keep an eye on my Discord. I'll maybe make an announcement and figure out how people would want to go about something like that. Hey, Simplyfacts, what's up? I don't know if I want to dedicate more stream time like I do to the general relativity reading group, but maybe we can. I don't know. Tell the anecdote about the biologist thought they invented integration by trapezoid method. I don't know if I've heard about that. In what case does centripetal acceleration decrease? Centripetal. Oh, so centripetal is the one that I actually remember. Centripetal acceleration would decrease. Okay. Abandon general relativity dream, study complex analysis. General relativity is so cool though. But no, I absolutely need to study complex analysis. So I'm gonna do that. If a particle is moving stably in a circle and has constant centripetal acceleration, do we say it's AC? I don't remember. Yeah, I guess we could think about this in two ways. Oh, Moomin, you may switch over to the Twitch chat. I can take a look at that in a second. Yeah, I guess we know that AC is equal to V squared over R. And so it decreases either when you're slowing down and coming to a stop, because the slower you're going, the less you need to accelerate towards the center. Or you're increasing your radius. That's when centripetal acceleration would decrease. So if your tangential acceleration starts out as V and you decrease it down to like V over 2 or something, or you start moving in a circle, but you kind of slowly spiral out and the radius gets bigger, that's another way that your centripetal acceleration could decrease. I have a bachelor's in applied math, Moomin. And since you're over on the Twitch side, there's a whole bunch of streamers on math streamers on the site who do math help besides just me. I'm probably the least qualified one. So there's a whole list of people if you're interested in more math streamers over on Twitch. On YouTube, there aren't really as many. It can be after this famished, or after Moomin's. Okay, so there's a slope, takes a roll 2. Oh, interesting. Oh, yeah. So wait, what do you want here, Moomin? Like, which one? I guess you probably want the first one. Any question? We're saying vector transformations, right? Um, Donda's math merch. The second one, actually. Probably not for a long time. You want to do the first one? Okay. I was trying to get a sense of what they all were like. First or second? Okay, I'll just choose the first. Why not? Okay, let me, I guess I'll take a screenshot of this. Oh, I don't have exclamation point song set up. It Syntax Terror by Nightstop somehow? Syntax Terror, a weird name. Do, 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 do. Yeah, it's syntax error. Oh my god. It is use syntax. I need to drag in one more question here, part D. Okay. So what's happening here? On the grid, draw the image of shape A after a translation by the vector -2, -6. Okay, so they're saying a translation here. So a translation means you pick something up and move it. So we're taking the shape A here, and we're going to pick it up and move it in some direction. In 3 days? Oh god, good luck. So the direction we're moving in is -2, -6. So it means the x values are going to go down by 2, and the y values will go down by 6. So I think maybe like you think about us taking the entire shape, shifting it left by 2 and down by 6. Or what can be a little bit easier to track for doing actual math is look at just the corners and translate those. So this first corner is 2, 5. So we're subtracting 2 from the x and 6 from the y. So 2 minus 2 is 0. So we're going to have a 0 x value. 5 minus 6 is -1. So if we call that like a, well, I should, small a. Small a, small b, small c, small d. That's a right there. Small b is the point 6 comma 5. So that's going left by 2, so it's going to go to 4 for the x, and down by 6, so negative 1. So small b is right there now. Small c is the point 4, 3. So then 4 minus 2 is 2. 3 minus 6 is negative 3. Okay, and then d is 2, 3. So 2 minus 2 is 0. 3 minus 6 is negative 3. All right, and then we just connect the corners, and that's our translated A. Sad. You can be after the sad, yeah. Oh no, you would be second in line after this. I have this question, another question, and then I could work on yours. Okay, so that's part A done. Sounds good, said. Center 4, 4. Enlarge A by a scale factor of 2, centered at 4, 4. Are we... So... Are we doubling the distance? Like, from 4, 4 to C, for example? I think that's how we're doing this. And then... we can presumably figure out what all the rest of the points must look like after that. Okay. Oh, God, you saw. Thank you for the kind words. I saw that for a split second before you attracted it. Okay, so I'm gonna, I guess, copy this. Okay, so for B1 here, I think how we would do this is 4 comma 4 is right there. And if we're scaling it by 2, then I guess all the distances away from this point should be doubled. That's how I'm thinking about this, at least. Well, I'll have to see what it looks like once we actually draw this. But the points on the shape that are easy to get are like just going in a straight line. So like the point right above it, the point right below it, and the point to the left of it seem easy enough to scale up to me. So the point from here to here, that's a distance of 1. So if we're scaling it by 2, we're going to double it to 2. So that's a point right there. The point up here, we're going to double it. So put it up here. Any help for homework? Just searching for an idea. You can put it in math discussion then, God, you suck. Sad, the chat up there is only the Twitch chat. The YouTube chat, there's a policy in Twitch saying I can't show both chats. One Piece is real. So I only show the Twitch chat up there. I wish I could show both. I might just start doing it anyway, but I don't know. Okay, then the point on the left side here, it's already distance 2, so if we double it, it's going to be distance 4. So we're going to go all the way over here. Not your guide. Thank you for the follow. And so now let's start to fill in the actual shape here. Oh, you're sad. Okay, nice. And so, we know this distance here should get doubled to 4. So it's going to come all the way over here. There we go. Okay, so I think this is B1. Centered at, so we scaled up by 2, centered at 4, 4. And we can check the scaling is right because each side should be double of the corresponding side. And I think it is. For B part 2, write down the scale factor of the enlargement that maps the image in B1 back onto shape A. Well, surely, if we just scaled something up by 2 and we want to undo that, unless I'm overthinking, or unless I'm underthinking it, you just take the number you scaled by and flip it if you want to undo it. So 2 flipped becomes 1/2. Yeah, there's people in the Discord who know some advanced math. It's not like the biggest Discord ever, so there might be someone who knows the type of math that you're doing, but there's definitely a lot of knowledgeable people. Okay, so then for part C here, we're mapping the small shape A onto shape B. So I can see B is horizontally flipped, like the diagonal part is over here on the outside. So it's not just a shift, it has to be a reflection. And so if we're going to reflect it, we should just figure out whatever line is halfway between them and say we're reflecting it across that line. So I think this line right here at -1, because it's 1, 2, 3 to A, 1, 2, 3 to B. So Moomin, thanks for the follow. Oh, are you out of here, Moomin? Do you still want to see this problem? Or Savage, are you the one who's leaving? You think you're out? All right, fair enough. Well, I have this little bit helped you out then. I'm going to move on to the next person asking a question then. Okay, famished. I see Cytos is looking at it too, but you're confused by step 3. Sub-channel Discord people say their math expertise slash preferences. Yeah, I mean, I can think of a few ways to accomplish something like that. I don't know what the best way would be, because like I could do separate channels for different topics. I could do roles where people can mark themselves as interested in various parts of math. I'm not sure what would be the best. I'm not a huge fan of like being able to mark or like I don't know. I mean, I think I'm just overthinking it, but people being able to mark like their degree level feels a little like I don't know. Like I wouldn't want someone with like a lower degree level to be dismissed just because of that. But like saying you're interested in a topic area, I definitely wouldn't mind. GCF, yeah, greatest common factor. Um, what's happening in this? Factor by trial and error? That's a pretty real way of factoring. Oh yeah, that's basically how I factor. Yeah, yeah, yeah. Why are they talking about factors of 8? Oh yeah. Um oh, Saido's I think is saying like the slide and divide way of doing it, which I never learned. Um Russian order theorem is underrated. Oh, I don't like it. You always use the quadratic formula. Honestly, I would do that for this one too. I mean, no, I would do the Gaussian check, I think. But famous, the way that I think about these is okay, let me 8y squared minus 6. So I think this is like filling in the blank and then just trying things until it works. And we can be informed on the things that we fill in the blanks with. So this 8y squared, it has to come from something times the first y times something times the second y. And so the only way to get that 8y squared is to either have a 1 and an 8 or a 2 and a 4. And the same thing is true for negative 6. The things that have to go in, like the negative 6 only comes from that times that. And so it could be we have a whole bunch of possibilities to check here, but like it could be a 3 and a 2, one is positive, one is negative, or it could be a 1 and a 6, one is positive, one is negative. And so in the same thing, like here. And you can also like flip these, and that's important too. So there's a whole bunch of possibilities. There's actually too many for me to want to write them out right now. Or like I wouldn't want to write out every single possibility, but that's how we think about this. Like we know what the numbers here have to be, or what the possibilities are, like, and there, and there, and there, and from there it's a matter of finding the right combination. And so that's where the guess and check part comes in. So if I was factoring this, yeah, it's a little bit weird. Like, this is how I tend to try to factor these, but it's kind of difficult to explain. I might try doing like 8y, a y. Okay, yeah. I did it in my head, but I'm thinking like, in order to make the 13, 8 times 2 is 16. So this would give us an 8 times a 2, and that would force this last thing here to be a -3. And now we multiply it out and check our work. We get the 8y squared. We get the -6. 8y times 2 is 16y. -3 times y is -3y. And don't you know? Or wouldn't you know? That gives us a 13 right there. Standard trick multiplied by 8, you get a square in the first term. The polynomial in 8x. Is that the standard trick? Oh wait, oh yeah, I think that's a form of like slide and divide, as I've heard of it. Okay. So, sad, or I forget the Twitch name. Oh yeah, not. Let me know what your question is. And God Usopp or Tom Hagen on the Discord, I'll show what you put in the Discord in case anyone wants to bite. Currently writing thesis on the paper geometric cartography identification by angle trisection. Considering I'm doing something related to it, but building a GUI for the protocol feels a bit redundant. Didn't have a creative idea for an implementation. I'd have to go and I guess look at the actual paper to understand what's happening here, but if that sounds interesting to anyone, it's in the math discussion on Discord, so feel free to have at it. Is an angle trisection impossible? Why can't you trisect an angle? I don't see an issue with that. If you have a 60-degree angle, you could divide it up into 3 20-degree angles. Oh, like constructing it with a compass and straight edge, it's impossible. Okay. That's kind of funny. Oh yeah. Okay, fair. Ria log2 value. I don't know. You need to give me something more than that to go off of. I don't know what your question is. Oh, yeah, but for any people who jumped into the Twitch side of things, we had a few come over from YouTube. If you're on Twitch, there's a whole bunch of cool people who stream math out there. You should check them out. I have tried JE questions and I don't like them, Ria. I'm not very good at them. Just watch me and applaud. Yeah, there you go, Jasu. Don't let people tell you can't do something. True factor, you take the square term's coefficient, put on the constant, and factor that. I think I've heard described a different way. If I'm interpreting you right, at least. Talos Teaches is the one who I had heard about this from. What's up, Desmond? Okay, yeah, this is the same thing. It's kind of like it's very sneaky. Sum of the divisors of 2025. Is that a funny number? If you want, God, you stop, yeah. I'm not factoring that by hand. Ugh. I don't want to add that by hand. I mean, okay. 1 plus 3 plus 5. No, it's being blocked. You always expect a round of applause. You know, slay, Jasu, slay. I hope there's going to be some type of funny reward for figuring out the answer to this question, and I'm not just typing in numbers for no good reason here. Is it a perfect cube? 2025 is a perfect cube? And no, I don't subscribe to like a newspaper called Perfect Cube News or whatever it would be. Well, I assume we don't include 2025 itself. Square? Do we include the 2025? That's not 3751. I don't get it. Quirky on the keyboard. What's 2024? 25. What's significant about this? I still don't get it. 2025, what's the square root of that? $45? Oh, yeah, yeah. 45 squared. Oh, you literally said it syntax. So I get two Cytos. I don't know if that's significant or not, though. Oh, well, yeah, that's what you're talking about, Zach. Yeah. Very good, Wolfram. You added them by hand, Cytos? Oh my god. Okay. Unless someone asks me a question, I'm gonna go back to linear algebra-ing, I think. And I was gonna choose one from orthonormal bases. Do I want to? Yeah. A tau number? What's a tau number? That's not 2 pi. Most beautiful. Well, don't say that around Zach syntax. E to the I pi equals -1, or I think people tend to write it as like e to the I pi plus 1 equals 0. But if you're Zach, your e to the 2I pi equals +1. Find the formula for the sum of divisors. Is there a formula for that? E to the 0I pi is your cousin? Mm-hmm. Oh, wait. Well, you said whatever, so I thought you were just being lazy. Well, wait, I thought you were referring to that one that's commonly, or like that one that people commonly say is the most beautiful formula in math. But that's just e to the 0 equals 1. Like, the I doesn't do anything there. Neither does the e. No, if the e is 0, it doesn't work. The I can be anything. E to the I plus pi times 0 is 1. Oh my god. It's true. Most basic and impressive thing in math is e times pi and e plus pi cannot be rational at the same time. I don't think I've heard of that result. One of them... Wait. E times pi and e plus pi rational. Like, one has to be rational, one is irrational? Oh no, at most. Okay, that's a lot more boring of a result. If one of them turns out to be rational, like confirmed, that would be crazy. But this allows the possibility that they're both irrational, and that's what I would expect, at least. Oh, like transcendental? Do you mean? I don't know. That's true. E times pi minus pi times e is a rational number. A refactorable number or tau number is an integer n that is divisible by the count of its divisors. I've never heard of that. It has 15 divisors, though. I saw Wolfram Alpha say that somewhere. And 15 does go into it. Oh, I don't know why you would care about a tau number. It would be like incest in my eyes? I don't know what that means. But you made me snort. Oh god. My poor keyboard. Don't snort with a runny nose. It's not good. Oh my god. I actually I need to go blow my nose. I'll be right back. Okay. My nose is much better now. The transcendental number incest has brought dawn to his knees. Yeah, you exploited my nose. Patient, thank you for the follow. It's Friday? Oh, for you it's Friday. For me it's still Thursday. The landscapes? Oh yeah, I didn't see what screenshots were up, but they're probably from DayZ. I mean, there might have been some from like Elden Ring or Dark Souls. Most of the screenshots there are DayZ, but there are some other games in there. Both treating me polynomial coefficients, which are rational, but roots are transcendental. Huh. It's interesting, Mert. Happy hour somewhere in the world. Mm-hmm. Should walk into a bar and try and say that. Like 3 hours after happy hours ended. It's like, well, it's happy hour somewhere in the world. You don't drink? There's a lot of people on the internet who don't drink, and that's a great thing, but it also kind of weirds me out. Yeah. Not even water? Revoking that Finnish citizenship. Trying to say between applied math and pure, having a hard time, you typed in math on Twitch and it came up. Oh, nice. Welcome in, patient. Like, are you just like entering university? Oh, this is exciting. Since you're new, and there's a math niche on Twitch. So I'm not the only person out there who has a math themed stream. There's a whole list of people there to get you started, and there's even more than just that. Like Academy of Useless Ideas was hanging out here earlier. So I like applied math personally. I have a bachelor's in applied math and a minor in computer science, and I'm starting on a master's in applied math in the fall. You're still around? Oh, nice. Transfer student just did 2 years of community college, got into a few UCs. Nice. The end goal is to work in computer science, but computer science is too competitive. Fair, fair. Don does drink, maybe. I guess why are you interested in math in general? Like, do you like what classes have you enjoyed so far, or what are you interested in hearing about more? Because like computer science, you can get computer science adjacent stuff in both pure and applied math. So I could see that going either way. Those analysts and applied people in the community. Algebra is the holy grail. Diffie and linear algebra, number theory looks fun. There are all fun options in UD classes. Diffie and linear algebra. When I hear diffie, I definitely lean towards thinking of applied math. Adesh, oh, good luck with your exam. Number theory is definitely in the kind of in the, it tends to be in the pure math realm. It definitely is helpful in computer science though, and has a lot of applications. Yeah, you know, it's moral research and go study chemistry. Everyone's just gonna tell you to study the thing that they're studying. um, hmm. So yeah, it's hard for me to tell you like, oh, you should definitely go pure or you should definitely go applied. I think the best thing that you could maybe do is try to get exposed to different areas of math. Okay, yeah, or like ask questions like that. So I like applied math because I the lack of rigor. Yeah, that's actually a big one. But I think math is beautiful when you can see it solving a real world problem. I love that. Speaking of diffie qs in linear algebra, I love that the Lotka-Volterra equations give you a vector field that model how predator and prey populations interact with each other. Do they have an example? Oh, come on, that's shameful. You gotta have an example, Wikipedia. No, not like that. But yeah, they don't have the exact example that I'm trying to find, but I really love seeing that kind of like real world problem being solved. Um, Someone in pure math tends to kind of, at least a lot of the pure math people who I've spoken with, kind of really reject and are allergic to any application. But I think that mindset also lets them make high level statements about math that are kind of beautiful for that reason, where you talk about many different areas of math that in one sentence. In this, there's probably more to pure math than that, but that's kind of like the classic pure math thing that I imagine. Um, I think the thing about too is that if you enjoy proofs, pure math is your thing. If you don't enjoy proofs, applied math is your thing. um, that's maybe a little bit too simple, but um, yeah, and I guess like numerical methods also provide some pretty interesting kind of ways of thinking about problems too. Those are fun. Um, yeah, the thing I was gonna say before is that you could try checking out like math YouTubers, like Academy Uses Ideas has a YouTube channel, or like there's like the big ones like Three Blue One Brown and like Veritasium and stuff, and they tend to make videos that'll kind of introduce a topic of math to someone who's never seen it before. Um, and those will be like a good thing to watch and just see how interesting you find it. Yeah, like the discrete math proofs, they're really similar to pseudocode. Like discrete math is the exact that's the thing I'm thinking of with how pure math applies to computer science. Like graph theory, and stuff like that. Yeah. um yeah, like I'm sure like the Lotka-Volterra equation is the example of applied math that I like. There's not a lot of pure math that I like, so I'm not a very good representative of pure math. Um R.I.P. bozos. But like I'm thinking like I did watch like a 3 blue 1 brown video that like introduces like topology. 3 blue 1 brown. And I was like, oh, you know, that's kind of neat to at least know at a basic level how topologists think. Oh yeah, it's this one right here. So like, you know, topology is pretty squarely in the realm of like pure math. And so like, I mean, it's half an hour, so you could like, you don't have to watch the entire thing necessarily, but like, I think like the math YouTube provides a really good resource of like just getting the idea of what different areas of math kind of like deal with, how people in those areas think and stuff like that. Two main concepts for proofs on combinatorics, double counting, and bijective proof. Oh, I think I've heard that, Mert, yeah. Topology is one of the best topics on math, Mert says. I've never studied it, but I get the feeling that I wouldn't like it. Yeah, no worries. And so, since you say you're interested in like differential equations and linear algebra, he has a bunch of videos on those two things as well. And so, like, he has some videos on like partial differential equations, which would be, I imagine you probably haven't seen them before, and they'd be a cool thing to learn about. Because you normally learn about ordinary differential equations first, and then partials are the next step up. All right, see you, Syntax. Thanks for hanging out. But yeah, like it's like math YouTube, and then going around to the different math streamers and asking them why they like the type of math that they like. So like Academy's ideas would be a great person to ask why he tends to like I mean he does a bunch of different types of math, but like pure math is often focus over there. Don't pay attention to the hecklers, patient. Everyone just likes to tell people to study the thing that they like. But yeah, like e to the 2I pi would be another great person to ask. Why do you like waffle stomping math? You know, you can't choose what you love. And I just love waffle stomping, apparently. Economical and a good Catholic. I'm sold. Someone else on Twitch last night was complaining about toilet paper being a ripoff, and you used to think of waffle stomping. The movement is spreading. But $10, more people are waffle stomping to save money on toilet paper. I've had this thread open for a million years now, and I still haven't read it. What do you want to get rid of the big product? Do you call this big pie, or is it? I don't know what you call that thing, to be honest. I know it's like a summation, but with products, but I don't know what you call the actual. It's capital pi, I think. I don't know. Oh wait, you don't get rid of it. Hmm. No, I don't like this at all. Sounds awesome, patient. Yeah. Thanks. Yeah. I mean, welcome over to the maths side of Twitch. Arc de Triomphe. I've heard of that. Uh, that's not a map thing, right? That's just like a landmark. Oh yeah, it's that thing. Wait, that's not. It's that. Look at the shape. The best Twitch community? I won't argue. It's really awesome. What about it? One question. Oh, I don't know JE Advanced. I'm sorry. It's JE Advanced is like way too tough. Oh, hot big pie. It is the Arc de Triomphe. This is a sick picture, by the way. Man, France would be so cool. It's 1822 for a ticket? Okay, I'm not going to France. Never mind. No. It's pretty awesome. Ooh, let's try 10. Sim City? I never played a Sims game, actually. I've watched, like, my cousin play it, I think, when I was a kid. But I don't think I've ever simmed it up for myself. Manor Lords. Is that a new game? I feel like I've seen people that I follow playing it. Well, I never watched them, but like I can see like their category in my follow list. I don't know anything about it. So if they're all orthogonal, the only way for this to be true is if C is the zero vector. Um, I'm confused by their wording though. Not the wording, but I'm confused by the setup of this. Because I want to put it back into matrix form, but that's what we're doing in part B. Like, what dot product are we looking for here? Um. Oh. Yeah. Maybe the dot product they're looking for is Q2 dot Q3. We know is 0 because they're orthogonal. And so that implies C1 must be 0. I think that's what they want for part A. Implies C2 has to be 0. Q2. Nope. What am I looking for? 1 and 2. Yeah, I was just weirded out because asking like about the constants, and I was wondering like if it's a constant, then what dot product do they care about? But I assume it's this. B, it seems like the more natural way of showing this to me. Show that qx equals 0 leads to x equals 0. Since q may be rectangular, you can use q transpose, but not q inverse. Now that does throw a wrench in the gears. The whole equation dotted with q1. Oh. Oh, yeah. That probably makes more sense. I think I was doing... Yeah, I guess what I was doing doesn't quite make sense. See, if you dot it with q1, you'll get c1, q1 dot q1 plus 0 plus 0 is equal to 0. So c1 must equal 0 because q1 isn't 0. And likewise for the other ones. I'm not going to bother writing it all out. Okay. Thanks for the help there, Slim. Musical instrument? No, I wish. I have 0 musical talent, though. Nikhil Ray is asking about... Oh god, what is this? One minus x to the 1 over x? Phobos, hello. It's good to see you doing math yesterday. True, weren't you? I think it's a much smaller audience, though. Doesn't this integral have issues with being defined? A couple little ODEs. Mm-hmm. I'm thinking about if x equals 1/2, we're getting 1 minus... No, I guess... Never mind. For some reason I thought we were getting a negative number here, but we're not. So that's fine. X equals 0. Oh! I'm sus of x equals 0. That'd give you 1 to the infinity. So we would need to split it up with the limit. I want to look at that thing in Desmos. I have a feeling this is like a competition integral or something. It doesn't look like a integral that's easily possible. Whoa! Why were there dots? Is that just a Desmos error? No, I could see it being defined as only weird values. Going out on any moon. Even like Pluto's moon? Like, is it Ceres? I don't know, I feel like that's a pretty crappy moon. I mean, it could be cool. Like, it's nearly the size of Pluto itself. I feel like it'd be kind of eerie. I don't know. It'd be lonely for sure, though. Leather goddesses? I don't think I know that reference. Just two moons in the outer reaches of the solar system. That's true. You know, if you want to be a leather goddess, I think you can be. It's an integration bee? Hell no, Dessen. I don't really like integration bee problems, and this kind of feels like one. Um, okay, yeah. Integral of root tangent x. I've seen that before, and it's crazy. Uh, I'm not good at crazy integrals, Nikhil. Um, I at least technically know how to do the integral tangent x, so I've seen it, but before this one I have no clue. But I'm not doing either of them because they're both incredibly involved. This one I don't really know how you get started. Like it seems like a u sub to get rid of the 1 minus x might be helpful, but even then, like I don't quite. I feel like guessing is going to be more helpful than anything else. I mean, even then, no, that's a hard one to guess. I think I'm going to go back to the things I was studying. I don't know the crazy integrals like that. Um, what's special about Q transpose Q? I assume that's what we're supposed to do here. Um, oh, yeah, you get because certain things are orthogonal. Is that just the identity? Yeah, it's the identity. Yeah, that makes sense. So yeah, okay, that just gets you directed to x equals 0. I like that a lot more than the first one. The first one is kind of slick though. What's up with 12? Anything about umbral slash discrete calculus? Uh, I've heard of them. What is umbral calculus again, though? Discrete calculus, I feel like I kind of remember, like the discrete derivative. Certain shadowy techniques used to prove them. The shadowy side of math. The dark underbelly. Second one is more algebraic. Maybe Don can become the good guy. Ugh. Freaking algebra. Behind the scenes of calculus. Oh god. Um no, see, I don't really know much about it. If you want to ask about something particular about it, I can try, but I I, I never really have looked at it. A1, A2, A3 is a basis for R3. Any vector B can be written as that. Yep, because it's a basis. Suppose the A's are orthonormal. Show that x1 is equal to A transpose B. A1 transpose B. Well, don't you just multiply each side by A transpose? Then we can think about the vectors. Nope. It's transposed. I guess it'd be like this. It's kind of a stupid way to write it. I should do this and then put the transpose on the outside, right? But basically if we split up into equations, x1 is just going to be A1 transpose B. I guess dot B. No, not dot B. Do vectors have to be orthogonal to be considered a basis? No. Orthogonal it gives a lot of convenient properties, but you definitely do not have to be orthogonal to be a basis. Then I have a question. I'm just wondering if you knew it. You're trying to self-study and to discover a lot on my own. Then you're gonna get stuck at some point. Oh, fair. Yeah, it's one of those things where I don't. I don't typically hear people asking questions about it. That's not a super like popular area of math, I don't think. Yeah, I guess you'd say linearly independent and they have to span are the two like keywords. Suppose the A's are orthogonal in part B. So if they're orthogonal, we get a different result for A transpose A, I think. Is that it? They don't just cancel like they did in part A. If a DNA sequence of length A is constructed using 4 nucleotides with repetition allowed, how many possible sequences can be formed? Let's say I don't do biology, but I guess that's a math question, isn't it? Right. Assuming there's no other rules to DNA that I need to be aware of. I guess it is just a combinatorics question. It's been so long since I think I learned about these in high school once, and that's it. Oh wait, but aren't the nucleotides in pairs? I feel like there's rules here that I don't know. But like you have like one nucleotide there and one nucleotide there. Someone's just calling 4 to the 8. Each one has 4 options. So I am misremembering this or overthinking it. Okay, well, that's 2 votes in favor of 4 to the 8. And it's just because you have 8 things, and each one has 4 choices. Is that 4? 5, 6, 7, 8. And so you have 4 choices 8 times, gives you 4 to the power of 8, I guess. Eight to the 4 is if you have 8 options 4 times, but we have 4 options 8 times. What does it? I'm saying would be 1/2 times 4 to the 8 because each one could be rotated. That's what I don't know. That's what I don't know the rules of DNA are. Because I thought they came in pairs, but we haven't addressed that at all. And Sadhik, yeah, I'm saying that wrong. I'm sorry. A cross B is not equal to B cross A. We can do that. I wonder if there's a simpler way than what I'm thinking. Oh. Oh, like that? I feel like that wouldn't. I assume the order matters. I don't think I feel like reversing it would be a different thing. I don't know though. So for the A, are you still here? Sudhikaya? I'm sure I'm still saying it wrong. Uh, you're asking to prove A cross B is not equal to B cross A. I think it would be true if there's a negative in front. I think that's a thing, but um, the direct way of doing this would be to, oh well, no, the yeah, Mr. Oh, Mr. Space Smiley Face. Fantastic name. Thank you for the follow and the prime. Holy crap. I really appreciate that. Welcome in. Yeah, I can see that with the right hand rule, it would put a negative sign there. I was about to go do like two 3x3 determinants, but then I realized the cross product is that can be 7x7, or like, you know, it doesn't have to be 3x3. I I wonder if there's something. It's like that explanation of the right hand rule, like it makes intuitive sense, but it's not necessarily like a proof. Can we show that the magnitudes are like the negative? Oh, I guess they wouldn't be. No, the magnitudes would be the same. It's always positive. I thought that the cross product, it's not for every dimension. I thought it's like 3x3, 7x7, and I thought it goes by fours or something. Orange Shoes giving us a light show. I don't know how you really prove that easily. So oh, it's the morning for you. Nice. Yeah, I mean, I guess I lied. I do know how you prove it if you do it like that, Fembox. I just kind of wanted to avoid that. Or I also, it's also not hard because the cross product I think is definable on higher dimensions. Not every dimension, but some dimensions, I think. Oh, that's it. Thank you, Stack Exchange. That's the way I was looking for it. It's swapping two rows into determinant. Much easier. I'll still just do it with 3x3s, but the same argument would apply to higher dimensions. If you swap two rows in a determinant, you negate it. So if I swap the bottom two rows, that's much nicer. And so then there's a minus sign now, and this is B cross A. That's how I would do that. A plus B cross A plus B? Buzz, I didn't know you were streaming. Oh, it is Thursday. Welcome in, everyone. Uh, I hope your stream was good. If you need to go take a break, please do. For anyone who's new here, my name is Don. I do math help streams. I do general relativity study streams on Saturdays. I also stream video games. And yeah, we're just working on a little proof of why the cross product doesn't commute. Or I guess I think you call it anti-commutative because there's a negative sign. And I think the simplest thing that I can think of is relating it to swapping rows in a determinant. Oh, and I forgot. For anyone who's here on my end, check out Buzz. He's awesome. He's usually doing some type of like coding stuff, but he's also super good at physics and math. What? So your idea, Slim, is to look at A plus B cross A plus B. Just need to know the cross product is linear in each term. Don does math C. Hey Reaper, hope you're doing well. The cross product is linear in each term, and that the dot product of a vector by itself is 0. Problems are boring and tedious, we got through them. All right, grinding them out. Does this distribute? How does this distribute like a normal multiplication? I think it does. But I don't quite know where the dot products come in. Oh, that's what you mean by being linear in each term. Okay. Territar is saying cross product vector with itself is 0. Yeah, yeah. So that zeroes out and that zeroes out. So what does that do for us? That's where you go from here. And so, and sorry, I'm behind on the YouTube chat, aren't I? Links, YouTube that deletes links. Oh, the left side is 0. Aha. That's a neat proof too. Okay. I like that. Yeah, and for that proof, you don't even need to know properties of the determinant. You just need to know properties of the cross product. Okay. Over the YouTube chat, Alez. Okay, you asked a couple of questions, Alez. Or That one about odd numbers got answered, it looks like. Draw the graph of y. Oh, that's using a twice. I'm gonna assume those are different a's. But you have a equal to I minus 2j plus 3k. The part where I'm confused is that in B, we use a again. And I don't think that's on purpose. Okay, so we can call that alpha, and I guess that works. But it looks like the same character to me, at least, in the YouTube chat. And so we're given that a dot b is 10. So I would just dot these two things here, and we know that it should also be equal to 10. So 1 times alpha plus -2 times -1 plus 3 times 2. So we just end up with 10 equals alpha plus 8. So alpha equals 2. Mm-hmm. Yeah, no worries, Elez. Especially that's to the orthonormal basis. IJK or orthonormal, which why the multiplication is so easy. Oh. So if you have, I guess, a dot product or an inner product for a non-orthonormal basis, is that a lot more difficult? It's Alex? Okay. But your name in the YouTube chat is Alez. I don't know why people do that. I know that at some point in math when you um like you stop talking about the dot product and you start talking about the inner product as like a generalization, and I'm assuming that's one of the areas where you need that generalization, but I never actually, it's never come up in a class that I've taken. Orthogonal vectors, two vectors are orthogonal if a dot b is 0. That's like the biggest thing to remember about orthogonal vectors. It means they're at a 90-degree angle. If you know which pairs are orthogonal, you just do the dot product for each pair. And if they all come out to be 0, then they're all orthogonal to each other. Mr. Space Smiley Face. Very catchy name. Geometrical means its projection has no length. Oh. Yeah. I never thought about it in terms of projections, but yeah. I guess I have it, not like quite in those terms. Okay, we got one last one from Alex before you go back to studying. Do, do, do. And that's 7 to the power of 2n. Oh, by the way, Mr. Spaceman Face, or anyone who's like lurking who might be interested in math streams, I do like to let people know that I'm not the only person out there who does math on Twitch. This niche does exist, even though it's small. There's a list of people who I tend to like recommend to do math help. There's also Academy of Useless Ideas. Who's hanging out here? Um, 7 to the 2n plus 7 is divisible by 8 for all integer values of n. Oh, positive n. Okay, good. I was like, for all integers, that'd be annoying. Okay, so if we're told here to do induction, so for induction, we need to start with the base case. Well, let's start with the thing we want to prove. We want to prove 7, that's not 7. That's 7 to the 2n plus 7 is equal to 8 times, I guess, some number L, where L is any integer. That's what it means to be divisible by 8. So we start with the base case. N equals 1, because that's the first positive integer. For n equals 1, we get 7 squared plus 7. That's 49 plus 7 is 56. And 56 is 7 times 8. So the base case checks out. Yeah, I do feel like you don't necessarily need induction for this. I don't quite know how to do it exactly for divisible for this exact thing being divisible by 8, but I feel like you often don't need it for a thing like that. Well, they say positive integers, so that's why I went to n equals 1, but I just we need to assume the induction hypothesis. And Alex, yeah, we assume that this is true for some k. For some integer k. Like this step is kind of annoying. I tend to not replace it with k, but you are supposed to do that. Oh yeah, doing it mod 8 might be easier. Now we try and prove it for k plus 1. Ooh, parentheses are important. Milk, I think you're supposed to assume it for a different variable. I forget the exact reason why, if you're being perfectly accurate. I usually don't bother doing that. But from what I've learned, you are technically supposed to do that. And so yeah, the thing that we do, or yeah, you probably just do this instantly if you use modular arithmetic. I don't think that we're supposed to though. When I try to do a proof by induction, you start with this thing and you try your damnedest to apply this any way you can. That's kind of how I think of it. So like torture this equation until you can apply the induction hypothesis. So let's start just multiplying out that 2k plus 1. No, I'm sorry. You assume this is true, but you start from the k plus 1, and you use the assumption somewhere in that proof. These are, you're right, Milk. These are different L's. You're, okay. Point, yeah. M, for some integer M. That actually could be important, yeah. But how can we fit this in? It doesn't really. The thing I was hoping to do is to make it 49 times 7 to the 2k. But that doesn't really help us, I don't think. Oh. Yeah. All right. Add in 49 times 7 to... That could be an interesting thing. Oh, yeah, Milk. I think I see where you're going with that. And I think... I think I like Slim's idea because it seems a bit more... it seems a bit easier to spot. This 7 to the 2k, we can replace with 8L minus 7. But yeah, yeah, you guys are ending up doing the same thing. So 7 to the 2k is 8L minus 7. So we get 49 times 8L minus 7 times 49 plus 7. Oh, yeah, okay. I'm going to factor a 7 out. Because negative 49 plus 1 is negative 48. And now we can factor an 8 out from the inside. 7L minus 6. And now that we have this 8 isolated, we've shown the thing that we want to show. There's a factor of 8 here. This, on the right side, the equals to 8m part maybe isn't the most necessary thing to write. There's probably a cleaner way of phrasing this proof, but I think that's the idea. As soon as we can get that there's a factor of 8 there, we're basically done. In territory, that's an interesting idea about taking the differences. I have a hard time thinking about whether that would work or not, though. I don't think you'd usually do that for induction, at least. I mean, you probably could and sell it as equivalent. generalized version of this, n plus 1 to the kp plus n plus 1, so I have to look by n plus 2. Oh, okay, Territar. Huh. Ugh. For an even k. I don't know. Um, that might be it for me for the day though. I can feel uh my voice is starting to fade a bit here. It's like a nice place to call it. Tartar is saying there's this k such a fk is divisible by 8 follows fk plus 1 is divisible by 8. Yeah, that seems like a pretty natural thing, Tartar. Fair enough. Yeah. Thanks for hanging out, Phobos. I'm gonna, I guess, end the YouTube stream, then on Twitch we'll look for a raid. So yeah, Territar, Alex, Mert, anyways here on YouTube, thanks for being here. I'll be back on YouTube on Saturday. That's the day. It's been 4 hours, make it prime. No, I went for 5 hours on Tuesday and it took a lot out of me. You have a good rest of the day too, Territar.